Yeah, it's audible. It's audible.
So we just had a technical glitch, sir. I think we have finally overcome it. And
Yeah, that's a problem. Yeah. Good afternoon
okay,
to all of
so
you.
yeah, good afternoon, sir. So I'll just have a brief introduction of this session, sir.
Yeah.
Good afternoon and a warm welcome to all the participants on behalf of the Confederation of Indian Industry. It is a pleasure to have all of you, and thanks a lot for taking out time from your busy schedules for this session. Now, vacuum pumps, as we all know, play a vital role in the performance of a paper machine. It influences the dewatering efficiency, the specific energy consumption, and to an extent, the productivity of the paper machine as well. The specific energy consumption of a vacuum pump can vary anything between 85 to 115 kilowatts per metric ton of finished paper, depending upon the type of paper that is being manufactured. And traditionally, we have seen that liquid ring vacuum pumps have been deployed in paper machines for this particular application, for dewatering application. Now, the issues or challenges that we have been told by the industry stakeholders with liquid ring vacuum pumps is one, it loses its efficiency drastically over a period of 5 years. Two, the performance of the liquid ring vacuum pump is impacted by the ambient temperature because the sealing water which is used in liquid ring vacuum pumps, its temperature varies with the temperature of the ambient. With these feedbacks in mind, we came up with this particular session. It is a session on vacuum system modernization in paper mills from liquid ring vacuum pumps to Maglev vacuum pumps. And I'm more than delighted to have our presenter, Mr. PK Ramesh. He is the Director, International Business and Technical Marketing, Shandong Tianrai Heavy Industry Co. Limited. He has over 24 years of experience in industrial engineering, energy efficient technologies, and global business expansion. A technical marketing and business development leader leading the promotion of magnetic levitation maglev turbo vacuum pumps, blowers, compressors, chillers, and heat pumps across global markets. He has successfully led the first installation of the very first maglev vacuum pump in India. He has contributed to over more than 600 industrial installations across the pulp and paper cement, chemical, pharmaceuticals, power sectors, delivering significant energy savings and operational improvements. His expertise includes maglev technology, vacuum systems, industrial energy efficiency, technical marketing, and international business development. So, a very warm welcome to our presenter, Mr. P.K. Ramesh. And before we start with the presentation, I'll request Mr. S.V.R. Krishnan, sir, who is the president of IPTA, vice chair of Papertech, and of course, as we all know, CEO of Shripati Paper and Boards. Sir, if you may please give a brief opening remarks on this session, uh, it would be great to move ahead with the session, sir.
Yeah, thank you, Mr. Vinay, and welcome to Mr. PK Ramesh. And it's really a very important topic as of today. The pulp and paper industry. Okay, we all know, people whosoever is attending, they all know in the paper mill that it's a vacuum system, and the refiners and the drives are the major energy consuming sections. So people are taking a lot of measures to reduce the specific energy consumption. But as you rightly explained, that compared to the traditional, liquid ring and water ring vacuum pumps and these type of pumps, you will have a lot of, at least, our turbo blowers and recent these type of vacuum pumps, I think wherever we have used, the energy savings were to the tune of minimum of 17% to 20-24%. So that's a big money for the paper mills today. So I'm sure Mr. Ramesh will throw a lot of light into the efficient way of operating these type of pumps and realizing the benefits. People are putting capex for saving some 25 to 30% of energy. There were run-tech pumps, there were man turbo pumps, and there are other pumps also, the turbo blowers, etc. Like Maglev turbo blower. And to just share with the team that we have also added one for our Satyamangalam unit, TRV 200. Okay,
Yes.
it's just to be installed and commissioned. So in fact, I would like to know more about the efficiency of these pumps and the salient features compared to other turbo blowers and vacuum pumps. Over to you, Mr. Ramesh. Looking forward to learning from you. Thank you so much.
Thank you very much, sir. Really, is really encouraging, and thank you for Mr. Vinay Vijayan for giving us this great platform to share our experience and knowledges. Thank you so much. And really, sir, I appreciate Sripati has already moved forward, and you trusted this technology and added pump. So we are going to install in very soon. Okay. So thank you so much. Good afternoon to all. And I quickly get into the technology and what is the difference between first generation, second generation, third generation. We always, I just take 1 or 2 minutes to introduce myself. I'm basically mechanical engineer, and I spent most of the time in design and development. I worked for Tata Group 5 years, and also I worked in Larsen Tubro. Larsen Tubro, like L&T 5 years. I worked as a design engineer. I also worked with Caterpillar in Chicago plant, USA, as a senior design engineer for a couple of years. So, being I spent most of the time in research and development, and also I spent some time with the BHEL R&D as well as DRDL, Defense Research Development. So I understand the mechanical and electrical, how the equipments are contributing more for the country development and these things. So with this background, the last 15 years I'm spending my time in vacuum pump, exclusively only in vacuum pump. That I introduced Zibo water ring vacuum pump in India. That was a Siemens technology. Before it was a cone type. The watering vacuum pump was introduced by KSB 130 years ago. That was cone type watering vacuum pump. Then after that, Siemens came up with a disc disc plate, we call it as a Siemens technology. That is also watering vacuum pump. So that I introduced 10, 12 years ago. That was the latest technology at that time. In China, there is a company called Zibo Huacheng. That's the company who developed the world largest vacuum pump, watering vacuum pumps. So I was representing that company, and I developed that market in India and sold more than 400 pumps in India. Yes, even right from Sripadi and all any big group you name, I have sold that. But what happened that watering vacuum pump, one common complaint is the power consumption. That was because the impeller is very big and lot of water the pump has to handle inside the vacuum pump. So because of just to generate a vacuum, I understand that industry is spending a lot of energy to just generate the vacuum, means centrifugal, by using centrifugal force. Then I came to know a couple of years before that Maglev, magnetic levitation technology. But before that, there is a turbo blower. We all know that Runtech and Man Turbo. That I call as a second generation. The first one is first generation is watering vacuum pump, and second generation is turbo blower. Even the Sulzer is the company. I think I'm on a Sulzer. So 35 years before also, long back. But that second generation could not capture more market in India for two reasons. Number one, initial investment, that capital expenses, it's really high. And second is operating cost. I understand that every 2 years once and 3 years once we have to change the bearing. That bearing is very expensive, and you need a skillful people to replace the bearings and all. These are the two reasons turbo blower could not acceptable or got the market major like watering vacuum pump did. So now the third generation, I am just working on it. There's a magnetic levitation. So there's two concerns which our Indian industry was facing due to with the turbo blower. Number one is operating cost and capital expenses. Number two, the maintenance. These two things are completely eliminated, is being eliminated in this magnetic levitation technology. When I go to the presentation working principle, I will explain in detail how that operating cost and the capital cost is being saved. So this is the brief introduction. So now I would like to share one working principle video. This is a simple, it's maybe 1 minute video. You can clearly understand how the magnetic levitation technologies pump is using. So can I, if you permit, can I share the video now? Mhm.
Yes, sir, please.
Yeah. Okay. I share my screen. Okay. Is my screen is visible?
Yeah.
Yes. Now, yes, now you are seeing this. This is the main. We call this a main vacuum pump or main motor. You know, if you see the watering vacuum pump or turbo blower, three mechanical equipments you will be seeing, or I will say three equipments. One is electric motor, maybe 500 kilowatt, 300 kilowatt, one equipment, which has one shaft and two bearings and everything. Then another for the speed reduction, people will be using gearbox or some pulley and belt. Okay, I will say that that is second mechanical equipment. If it is a gearbox, again there is a number of bearings and frictions, oil, so many things. And the third one is the prime is the pump. The pump is also having a huge shaft and impeller, and again there is a bearings and all those things. So all these three equipments will be is being
This
replaced
webinar is
by
being transcribed and summarized.
Ah, these three equipments are being just replaced by this single equipment. You can say this impeller is, the shaft is only this much, maybe half a meter, and it is a titanium impeller. It's too small, maybe 300 or 400. I would say that millimeter width. So it's very simple. Here there is no bearing. I would say there's bearingless, no separate electric motor, no pulley and belt, no gearbox, and no big impellers and all those things. It's a very innovative, very intelligent equipment. It's a single shaft. Single shaft is carrying motor and everything. So I just run this video. So here you can see this is the simple equipment. Only we can say that one, two, three, four, or maximum five components. I'll explain one by one. So on your left hand side, you are seeing this impeller, that golden color. That is we call it a titanium alloy material, and the single shaft. There's a single shaft, and also you can see the center. There is a we can shaft a rotor, and position sensor is there. Position sensor two, and there is a radial bearing. I'll explain the function of radial bearing. And there is a stator we call it as a PMSM, permanent magnet synchronized motor is there. This is supplying the power to the system. And we have the another set of radial bearing, and there is one, finally there's a cooling impeller is there. So I'll explain one by one. There's a thrust bearing also. So the center shaft is first is carrying is a rare earth material. This is also a magnetic material. And we have the impeller is both are interference fit is a single unit. Okay. So we have this radial bearing. You can see this one and two, these radial bearings. Actually, there is a micron level gap between a rotor and the A and B, active magnet radial bearing. So that active radial bearing function is to give sufficient EMF force, electromagnetic force, to hold the shaft at the correct position. Because is at 17,000, the maximum RPM is 18,000 RPM, and the minimum is while operating, so 14,000 RPM. So when the shaft and impeller is running at a very high speed, that is in the air, in the floating in the air and rotating. So there is a possibility of movement of the shaft due to gravity. It may go down, or it may move in linear wise or something. To arrest this, we have a radial bearing, and we have the position sensor. The position sensor is in 1 minute 15 times, 15,000 times it is sensing or correcting the shaft. It is taking the position of the shaft and is giving the signal to our controller. We are supplying the control cabinet. Inside there is a controller. That controller is giving signal to the radial bearing to give sufficient EMF force so that that shaft will be kept at the particular x 0 comma 0 comma 0, that xyz position. So the radial bearing is taking care of the shaft movement, or I would say rotor movement, to arrest the radial movement. And we have a magnetic thrust bearing. Because of the suction is happening, there will be a thrust load. So because of thrust load, the shaft may move horizontally. So to keep the shaft at a right position, so we have a thrust bearing. The thrust bearing is giving sufficient EMF force to hold the shaft at the right position. So you know that bullet train and all concept, the same technology only. By using north pole and north pole, they will not this always ripple like that. So the radial bearing is north pole and shaft also north. So it is ripple, and also it is giving the continuous EMF force to rotate at a higher speed. So this is the basic technology behind this. So now the radial bearing and rotor and thrust bearing, these all magnetic equipments inside. And motor also, that is also permanent magnet motor. So by using this magnetic levitation, so when you switch on the motor, first step is the shaft will be levitated to the air, first step. Second, when the radial bearing and the thrust bearing is giving the proper signal, proper EMF force, so it is keeping the shaft at the right position and is running at a high speed. So when we do this here, we see no friction, zero friction, no oil, no grease, no sealing water, nothing is there. So when it is running at a 16,000 RPM, sufficient centrifugal force, by use centrifugal force, vacuum being created inside, and you can see the running position. So you can see here the gap between the rotor and AMB, active magnetic bearing. There is a gap. The shaft is rotating only in the air now. This movement is a thrust. This thrust bearing is taking care of the horizontal movement of the shaft, and radial bearing is taking care of the radial movement of the shaft. So this is the cut section of the equipment. Very simple. The suction and discharge is happening here on our left hand side, and there is a AMB, means active magnet bearing, and center shaft. In the center area is the motor stator. We can say that, and here there is a cooling fan. So this fan also rotating at a high speed and is delivering the air to the system for the cooling purpose. Okay. So there is a position sensor. So very simple and but very effective technology. Okay, so this is the video. If you have any question, we can discuss regarding this working principle. And if all okay, then I would like to move to.
Sir, I think you can continue with the presentation. We can take the Q&A after the presentation is over.
Sure. Okay.
Okay, sir.
So yeah, this is my. Are you seeing my slide, PPT? Mm,
Yeah.
Sir, your
Yes.
presentation is visible.
Correct. So I'm not doing any marketing or business here, only the technical knowledge sharing session. So I will not much talk about my company and details. So, but I would say that just two words. The Shandong Tianrui Heavy Industry is the company who first developed Maglev vacuum pump. It is the first company in China, and the chairman of this company is basically one of the key scientists in China. He is also part of the ministry. He develops these maglev blowers and vacuum pumps, chillers, like that, many equipments. Okay, so I just go in detail of the technical part now. This is a company profile started in 2008. This company has 500 patents, 500 all technical patents. So I have just a quick corporate video so that you can see how the manufacturing setup is there. So you'll understand. So this is a small video.
Tianruo Heavy Industries, creating a green future with Maglev power. Located in Weifang, Shandong Tianruo Heavy Industries Company, Limited, founded in 2008, is a high-tech.
So you can see this we call this the control cabinet. Here you can see the HMI panel with the Siemens PLC. This come with the panel only. So inside all kind of electrical equipments, control box, everything will be there. These are
enterprise engaged in the RN.
Yeah, this is the main motor. We saw the working principle, that is animated one, but this is the actual part. You can see the center part is the PMSM starter motor. Uh, Here this is impeller and a fan.
And manufacturing of Maglev.
So this is the vacuum pump. We call this a double stage. When the vacuum pressure is more than, for example, 66 kPa or 70 kPa, so we are giving double stage pump. If it is a less than that, there is a single stage. Yeah.
Energy saving equipment. It is the leading enterprise of Shandong Province's energy saving and environmental protection equipment industry chain, and a key leader in China.
Yeah, these all are single stage Maglev turbo vacuum pumps, single stage one, under inspection before dispatch. This is the company is having more than 70% market share in China in paper industry, 70%. So the production capacity is always full and they are busy. This is before dispatch, they are doing, the inspectors are doing quality check.
Is Maglev Industry. The company operates 3 campuses covering a total area of 165,000 square meters and has established an annual production.
This is testing lab, R&D lab. Before dispatch, each and every equipments will be tested completely as a whole.
Capacity of 10,000 units of Maglev energy saving equipment. Among them, plant number 1 covers 20,000 square meters and is mainly engaged in the production of rock drilling machinery and Maglev components. Plant number 2 covers 45,000 square meters and focuses on producing core Maglev components and developing new products. Plant number 3 covers 100,000 square meters, primarily used for Maglev motor assembly and full unit testing. It features China's first automated assembly line for Maglev motors, significantly enhancing product quality and production efficiency.
Sorry.
The company has established the Shandong
You can see.
efficiency.
This is the robotics. So the PMSM motors and all manual assembly is little critical. So this company has a complete automatic robotic system. So complete assembly will be done by robots.
And production efficiency. The company has established the Shandong Maglev Industry Technology Research Institute and owns 4 national-level innovation platforms, including the Secretariat of the National Standardization Working Group for Maglev Power Technology Fundamentals and Applications, the National Enterprise Technology Center, the National Industrial Design Center, and a postdoctoral research workstation. It has successfully developed 8 categories of.
Yeah. So total 18 products under process with the same technology Maglev. Now these are the 7 equipments which you are seeing is readily available for marketing and usage. You can see one by one.
Including Maglev vacuum pumps, Maglev blowers, Maglev air compressors, Maglev steam compressors, Maglev heat pump units, Maglev chillers, Maglev low temperature waste heat generators, and Maglev flywheel. These products deliver an average energy savings of 30% and reduce noise levels to 80 decibels. They are widely used in energy-intensive industries such as cement, papermaking, alumina, wastewater treatment, chemicals, and thermal power. The company is leading the development of China's Maglev industry toward the world's advanced level and injecting strong green momentum into the low-carbon transformation of the industrial sector. As of now, Tianruo Heavy Industries Maglev energy-saving equipment has been deployed nationwide, serving more than 2,000 enterprises across over 20 industries. Its products are also exported to overseas markets including East Asia, Central Asia, South Asia, Southeast Asia, the CIS, and Africa. Tianruo Heavy Industry holds a market share of over 70% in industries such as cement, papermaking, and alumina. Its products are also widely applied in wastewater treatment, petrochemicals, food fermentation, and other sectors. Going forward, Tianruo Heavy Industry will thoroughly implement the national directives on accelerating the development of new type productive forces, guided by technological innovation and driven by market applications. The company aims to rapidly build a well-known Chinese brand of maglev energy-saving equipment and contribute to global efforts toward green, low-carbon, and high-quality development.
Thank you. So now I'll go to installation video. So this is the video which we have installed in Russia. So I'll just run it here. So complete set, actual installation running. The pump is running now. You can see no vibration, no noise. Okay, so here I'll explain one by one so that you'll understand our complete scope of supply, means complete set. Actually, this is the Siemens HMI screen, you are seeing it, the home page. So there is speed and vacuum. So these are the two mode you can use it. For example, if you know the flow, you can just run it at the speed mode or vacuum mode. So here everything is a digital. You can enter the RPM or you can enter the pressure, everything here only. So this is the one, and we call this a control panel. So inside the control panel, the important part, controller is there inside, which is controlling the complete magnetic parts inside the AMB we discussed, thrust bearing and radial bearing, position sensors. So all will be controlled by the control which is inside, that will be assembled or installed along with the vacuum pump. So this is, will it comes with inbuilt air conditioning. So you can install it anywhere in the plant. So you don't need to any VFD room. And before this we have the variable frequency drive VFD, that also we supply along with our control panel and main pump. Because why we are supplying VFD? Because this is running at a very high RPM, 17,000, 16,000 RPM. So we have tie up with VFD company that called Innovance. Innovance, you know very well. This is the second largest company in China after Siemens. So they have a factory in Chennai also. The Innovance VFD we are using it. So the first equipment is VFD, and the second will be this control panel with all the PLC, Siemens PLC and controller everything. And the third equipment will be the main pump. You are seeing it. This is the main pump which is having all the mechanical equipments inside, including PMSM motor and all. This is the main motor. Then there is a junction box. From the VFD, all the supply will come to this junction box. Base plates, and this is the impeller, suction, and discharge. And we supply with the flexible joint, air bellow we supply, and also we supply this steam water separator. The what we are seeing it, this also we supply. What is the function of steam water separator? You will be having your primary water separator, which you are using for our watering vacuum pump. That will be your primary water separator. Then the delivery of primary water separator will be suction of this our steam water separator. So our steam water separator, whatever the water particle is coming from the primary separator will be removed. Although we have a inside demister system with a spray valve. So we spray the water and by using the condensation, this all the moisture also will be removed. All impurities, pulp material, all will be removed in this steam water separator tank. And the steam water separator tank is having two extraction pump is being supplied by Kenflow. This is China's number one extraction vacuum pump supplier. So you can see that one and two. And also we have a pressure level transmitters and pressure sensors, temperature sensors. You can see this is the extraction pump. Okay. And we have anti-surge valve. So you are seeing it now. So when the fluctuation happens in the paper mill due to various GSM or your machine speed changes or any fluctuation happen in the process, so the system is automatically bleeding or using the surge. Anti-surge is happening here. So we are supplying along with the anti-surge valve. You can see now the control system. This is a separated tank. So our scope of supply will be the entire equipments, the entire parts, whatever you are seeing in this video, including base frame and all those things. So one good point is, since the system is not having any heavy vibration or noise, we don't require heavy foundation. Generally for watering vacuum pump, we need a foundation bolt up to 800 mm or 900 mm, very long foundation bolt is required, and the civil foundation cost, concrete cost also heavy. But in our case, only 110 millimeter bolt, small 110 millimeter foundation bolt is enough to mount our equipment in your floor. That is another point. So this is the actual video from a Russian company, and another video I would like to show. This is also from another customer. Dual. There are two control panels. You can see. This is also running 600 kilowatt power. You can see there is no noise and vibration. Yeah. Okay, so I have the first installation we have done. Let me see this. This is the first Maglev turbine vacuum pump which we supplied in China. This is our first pump, 2008. That time HMS screen was an old one. Now, okay. So I also want to say important point, since the system is running at very high RPM. Our general question or doubt from our all Indian customer is, if suddenly power shutdown happen or something grid or some got off, so how the system will behave? Because it's running at a very high RPM like that. So this video will explain how our system will behave on there. Is comparing roots blower and our maglev, the both how it behave during power shut, sudden power shut. If sudden power failure occurs, the roots blower or watering vacuum pump will behave like this. Whereas our this maglev turbo blower will behave like this. So you can see the RPM from 13,000, sorry, 30,000 RPM to slowly it will reduce, gradually it will reduce to zero. Then So it means we have a intelligence system in our control cabinet. There is always power backup. If any power shutdown happens, so we will supply power. Means our system itself, the supply power to the system through power backup, and gradually RPM. For example, 17,000 RPM it is running. It will slow down like 16,000, 15 like this, and will come to zero. Until it comes to zero, the system will have a sufficient power. So that is inbuilt. I'll show another video which explains the same.
Magnetic bearing. The magnetic bearings keep the shaft afloat while it spins in a completely friction.
Yeah. So these are the sensors. So magnet, it is explaining how magnetic bearing is working. So we have electromagnets coil this. Sensor is there. The center part is the shaft.
State. Hyper-accurate sensors calculate shaft balance and adjust power to the electromagnets, correcting any deviations to within mere microns.
So here you can clearly see the gap between active magnet bearing as well as the shaft.
If a power loss
If the power lost, how it is behaving this?
occurs, the online DC power supply sends power to the magnetic bearings with virtually no lag time, keeping the shaft afloat and letting it set down gently to prevent any possible damage to machinery.
Yeah. So all these videos and PPTs can be shared along with this. So now I'll go to the our main PPT. Okay. Yeah. So we first discussed there are first generation, second generation, third generation. The first one is our watering vacuum pump, and second one is the turbine like Rentec, Man Turbo, and like the third one is the Maglev turbine vacuum pump technology. So first watering vacuum pumps 100 years ago and developed, and it is successful even now in India. 90% of paper mill is using watering vacuum pump only, the very old technology. But the second generation, even though the technology began in 1940, it's not very successful, that we already discussed, because of two reasons. One is initial investment, second is operating cost, like bearing and all those things. Now the third generation, compared with the first generation of watering vacuum pump and maglev turbine vacuum pump, the power saving is almost 40% to 70%. I'll explain how this. We have slides. When compared the second generation turbine vacuum pump, the 15% to 20% power saving. This is the decline. Okay, so this is all we discussed. Okay, now you can see this slide. There are equipped motor, bearing, transmission form, impeller, and noise, range of regulation, maintenance, overall efficiency. This slide is comparing all the three technologies: watering vacuum pump, traditional turbine vacuum pump, and maglev turbine vacuum pump. If you see the type of motor, it's a traditional three-phase synchronized motor, and our turbine vacuum pump also having the same. But ours is, we discuss magnetic motor, PMSM, permanent magnet. If see efficiency of the three-phase motors in 90 to 93 percentage both, whereas PMSM is more than 97 percentage efficiency. Life, due to heat and temperature, high heat and temperature, is having short life both. But whereas in ours the heat is low, and heat dissipation also, we have a proper cooling system, so it has long life. So the design life is 20 years. Bearing form is a ball bearing. This is tilting pad bearing, whereas ours is active magnetic suspension bearing. We discussed. These two bearings are watering vacuum pump and traditional turbine vacuum pump. Both are having high friction. Especially this turbine vacuum pump, the second generation, it is running up to, I think, 10,000, 11,000 RPM with a high speed. Due to a lot of friction, the bearing life is short. Maybe 2 years, 3 years once you have to change it. So our bearing, we are design life is 20 years. Even our company is giving 4 years replacement warranty also. It means this is the only company in out of three technology The Maglev turbine technology is giving 4 years warranty, whereas others are giving only single 1 year, because there is no wear and tear, there is no friction, no heat, vibration, noise. So the life of the parts is very high. And bearing efficiency, because of the friction is 94 to 96, where ours is 100% efficiency. Bearing life we discussed. And transmission form, if you see, belt or coupling or gearbox you need for transmission. And for the turbine vacuum pump, yes, you need a gearbox with the coupling. Whereas ours is no belt and coupling, there is no gearbox, because this is a direct connection, single shaft. And amplitude of vibration, it's high for both. Vibration is very high in watering vacuum pump and traditional turbine pump, whereas ours is very much minimum. And efficiency of the form is 95 to 96 percentage, whereas in turbine vacuum up to 97, but ours is 100% transmission efficiency, no loss, no transmission loss. And impeller, we know watering vacuum pump is a form, and positive displacement eccentric rotor impeller in watering vacuum pump. And turbine is a semi-open or closed three-way flow impeller. Ours is semi-open three-way flow impeller. The maximum dynamic efficiency is 89.8 percentage. And noise for watering vacuum pump is about 120 decibel in 1 meter distance, whereas a turbine vacuum pump is 90 to 110. Ours is less than 85 decibel. And impeller size, you know that watering vacuum pump range of regulation is less, whereas ours is a large range of flow and pressure regulations. You can have a big range. Maintenance, for maintenance, you know that watering vacuum pump needs lots of water, and there's a scaling and many issues are there. And you need lubricating oil, grease, and oil is always required, and control system is not there. Whereas turbine vacuum pump also, there is no sealing water, but oil is required for cooling oil, because it is a forced lubrication system. Generally, they use in turbine vacuum pump. So you need lubricating oil. And control system also, control and protection system are available, but regular inspection is required. In our case, no sealing water, no lubrication, grease, what, nothing. And the control system is intelligent control, and real-time intelligent monitoring also we can do. So overall efficiency, if we see, considering all the things, watering vacuum pump 40 to 45%, for turbine vacuum pump is 60 to 68 percentage, where ours is 87, the Maglev is 87 percentage. So this slide gives the complete comparison of all the three technology which is available now. Okay, so now comparison pictures we have seen between Maglev and traditional turbine vacuum pump. So you can see on your left hand side the traditional turbine vacuum pump. You can say Runtech or Mon. You see the lot of oil and leakages, and you see the atmosphere how it is. And if you see the Maglev vacuum pump, it's a dry and clean, because it's a 100% dry system. So this is a turbine vacuum pump. Some maintenance work is going on. You see this Maglev. Here, this same customer, he replaced traditional turbine vacuum pump. I think it's a Mon or a Runtech, I don't know. So they replaced with with this Maglev turbine vacuum pump like this. This watering vacuum pump, I think Nash is the watering vacuum pump. They replaced with Maglev turbine vacuum pump. You can see the complete system. This is the control cabinet, junction box, main pump, and this is a discharge. And the one important point I would like to see, you can see the heat insulation and all. Since the pump is running at 17,000 RPM, the exhaust hot air is a hot air, the dry air, minimum 105 degrees Celsius to 165 degrees Celsius. So it is because generally in India now they are leaving it to the air, but in China and other Europe countries, they are using this exhaust hot air, the waste heat. This is become waste heat. Actually, they are reusing it. How? They are inserting into their hood system, dryer hood system, By using the heat exchanger, you can use this waste heat. That's why you can see that to avoid the losses and all, they have a proper insulation. And there is a moisture separator tank installed. So rare application cases, some of the cases, very big paper mills in China, we have replaced watering vacuum pumps with our system. This actual data, you can say that case study. So this is the company Henglian Group in China. Shandong Henglian Group is a very big company. So they replaced 3 Maglev turbo vacuum pumps have been installed to replace watering vacuum pump. Okay, so replacing watering vacuum pump with the Maglev, these are the power saving 51%. Of course, water saving is 100%. Annual power saving is 4,49,000 kilowatt hour. Okay, saving steam annually is because of this exhaust hot air, waste heat. They are saving steam annually 965.9 tons, which is equivalent to 3,43,000 kilowatt hour, because they are converting steam tons into electricity power. So considering this is then steam saving is almost 31.2 percentage. So if you add 31.2 percentage and this 51, totally it is coming 82.2 percentage comprehensive energy saving rate. It's a huge. So when we replace watering vacuum pump with Maglev pumps, you will be having three savings. Number one, electricity power saving around 51%. Then there is a water saving 100%. Then steam saving. These are the three major savings you will be having it. This another company in November 2022, a Maglev turbo vacuum pump has been installed in the paper machine vacuum system. This company name is Leoning. Um, so here power saving rate is 65 percentage and water saving 100%. Annual is this. And standard coal saving, here they calculating coal 348.5 ton. And carbon dioxide reduction, CO2 reduction is this much tons, 650.5. Noise less than 80. This is the company name, Liaoning Zhenzing Ecological Paper Company Limited. Another Sichuan Xinjiang paper industry. This is also big. 5,600 paper mills in production. This is a decal width. Okay, width is this much. Speed is 780 mpm speed. GSM range is 125 to 160. Okay, so before renovation, watering vacuum pump they used. Installed power is 380 kilowatt. Ours is 350. Operating power was 356, has been reduced to 205. Power saving rate at 42 percentage. Annual saving is this much million kilowatt hour. This is another Guangdong paper. You can see 42% power saving. This is a decal width, machine speed 1000 mpm, 1000, and grammage is 37 to 85 tissue. Initial installed power is 1275, with our pumps 832. Even the installed power has also reduced drastically. And operating power 1103 reduced to 642. So 42% power saving. Another Century Sunshine paper is very famous in China. So again, installed is 922, ours is only 600. Here 50% power saving. Operating power was 843.3 kilowatt, reduced to 417. This is a group company. She find new materials. So here they have multiple specialty paper, wallpaper based decorative paper like this. These are four machines, PM1, PM2, PM3, PM4. This is the company. They have replaced entire. So the total power saving is 42, 43, 30 and 42 percentage like that. In September 2022, installed two TRV 200. The same thing we have supplied to Sripadi TRV 200. They ordered about to install, and TRV 300 also. So TRV 200 is giving 43 percentage power saving. This is actual data from the mill. This another Henan Xinmi Hengfeng paper. In China, 70% paper mill are using our Maglev technology only. Shanxi here 34.4 percentage power saving, and noise it was 110 before. Multi-stage turbine vacuum pump they were using 110 reduced to less than 80 decibel. Installed power from 450 to 350. This is Sichuan Nishi Paper Company Limited. This is a decal width 2850. Again, this is 1000 mpm. GSM is 12 to 20 GSM. Electricity saving rate is 47%. Then Henan Liuho Yanfang paper. This is also width is 1880. Speed, machine speed is this. Grammage is this is 45%. Shanxi on another 24% power saving. So this is you can see multiple Maglev pumps installed. Around 8. It's the biggest mill in China. APP, Asia Pulp and Paper. So they replaced all watering vacuum pump and they used around 8 sets in a row. You can see. Fujian Xingshan paper. The decal width is 5500 millimeter. Speed is 620, 80 GSM. They saved 50.9. It's a huge power saving. Rizzo, Asia symbol, 39.5% power saving. Guangdong Dingfang is another one. 44. Whatever name is in China's #1 paper mills is very big. This company in Thailand. In Thailand, we have installed. The name is Thai Cardboard Company Limited. So 53.8% power saving. The operating power 266 to 123, drastic reduction from watering vacuum pump to this. This also Thailand, BPM, customer name, and power saving is 44%. This is Malaysia, the Muda paper, 47.5%. This is a Malaysia team, the Muda paper team. So they successfully installed, replaced watering vacuum pump with Maglev. Operating power is 800, reduced to 420, just half. And TRV 200 and TRV 500. This also BM paper. Watering is also in, I think, Thailand. Watering vacuum pump replaced to Maglev and 49.4% power saving. So I'll show the site installation unit experience. So here you can see a different type of, here dual motor system we have. For example, if it's a TRV 500 means 500 kilowatt, that can be split into 250 kilowatt, 250 kilowatt means dual motors. So a lot of flexibility with the one motor can be start and stop like this. So if you see in India, there are different installation we have done in especially in Jani, Gujarat, Vapi. We installed like this PM1. Steam water separator will be on ground floor, and vacuum pump system will be on the second floor, above the mezzanine floor. In the total almost 12 meter, I think 12 meter height they installed. And also in PM2 in Jani, they installed like this in straight line. So both options are available. And the third one is like this. The parallelly also we can, if you have a space constraint, we can also install like this. And the fourth one is like this, L type. All these 4 installation methods are available. This is a double stage pump. This is single control panel, single Maglev and single steam water separator. This one is a dual. One steam water separator will have 2 separate pumps, Maglev pumps, and 2 separate control panels like this. So the VFD, frequency converter cabinet we supply. These are some photo reactants, air switch and all. This is a control cabinet. We have a HMI panel, emergency shutdown, and air conditioning is inbuilt air conditioning system. This we have seen HMI panel Siemens. So we use all international brand, all the means electrical equipments. This we supply all the Siemens PLC and relays and all. Yeah, this is the steam motor separator. Here I'll just explain how this we call it a demister. You can see this from your primary water separator tank, first level, it is coming to here the demister. Here there is a spray we are doing it. So when it is entering inside, there is a on stoppage. Here, due to condensation, is all moistures and impurities, water particles, everything will be dropped. So there are two here, one system, control system, and here. So this is the technology we are using inside our steam water separator. So 99.99% moisture, water, or impurities will be arrested here itself. Even though if any small amount of things are going inside the our Maglev pump, there is no problem because of the high speed. Immediately it will be thrown out through discharge. And if you feel that there is a scaling formation, it is forming even with this, then maybe 2 months once you have to clean the impeller. So we will give the training how to remove the impeller and clean it. So that system, that training this company is giving. Yeah, that's all. So this is the PPT that I would like to say almost now 4 o'clock 10 minutes. Yeah. Now we can enter into I think question and answer session. I briefly explained about working principle and also I explained the difference between first, second, third generation vacuum pumps and also what are the equipments are there in the system. I explained right from VFD to the exhaust, what are the equipments this company is supplying, everything I explained. And now Mr. Binay, I would suggest that we can stop now our presentation, then we enter into the next.
Yeah, sure, sir. Thank you so much for the insightful presentation, sir. It was truly a wholesome presentation. You have started with covering the different components of the liquid of the Maglev vacuum pump. You showed us the actual running model of the Maglev vacuum pump. You discussed the foundation, the footprint of the vacuum pump, the different scenarios, like what happens in case of a sudden power failure, how you are claiming that 40 to 70% of energy saving is there in Maglev vacuum pumps compared to liquid ring vacuum pumps. That also you explained very well, sir. You uh, showed us case studies related with not only the vacuum pumps, Maglev vacuum pumps, but also case studies where waste heat recovery was being done from the exhaust of the separators. You showed us the different types of installations of the Maglev vacuum pump on site. It was truly wonderful seeing this new technology in action on the screen, sir. So I'll request our participants to please share your questions on the chat box so we can solve your queries. The first question is from Mr. Nishal. What is the motor speed for this equipment, sir? I think
Motors,
he's talking about the dual motor maglev pump.
motor speed, that PMSM, right?
Yes, sir.
So here, motor speed and impeller speed is same. Maximum is 18,000 RPM. Is a single shaft which is carrying both impeller as well as motor. So motor speed and impeller speed is same, which is maximum is 18,000 for Maglev vacuum pump.
Okay. Now, second question is from Mr. Francis. What is anti-surge valve and how it works?
Yeah. See, when we are, for example, we are fixing 16,000 RPM for any vacuum, for example. So 16,000 RPM means that will deliver, for example, 300 MQ per minute suction flow. So keep on 300 MQ per minute flow will be delivering at 16,000 RPM. These are for example. Now let's see, due to the process change or machine speed change or grammage change, if the flow is decrease or increase, for example, It doesn't require 300 MQ per minute. It requires only 280, for example. So the balance 20 MQ per minute will be surged by using this anti-surge valve. It means it will be bleeded there. And if you need little more, for example, so it will be completely closed. So the anti-surge valve main function is to take care of the any fluctuations happen in the process. So anti-surge valve main is to keep the system under control. Whereas, for example, in watering vacuum pump, you might have seen there will be a lot of hunting will happen if the flow
It's
is
a little
demanded.
waste.
Yeah. Yes. So that is the function of anti-surge valve.
Okay, so the next question is how the power backup is given? Does it have any battery backup system from Mr. Sriram Gunti?
Yeah. So we do not have a battery backup, but similar to this, our this electromagnetic system, it's also having the EMF force stored in our system. So that stored electricity power will be used during shut off. So it is similar to battery backup only, but there won't be any separate battery like what we have UPS, some separate battery. That will not be any external equipment, but the same electricity will be saved in our magnetic component itself. So for that, I will share some detail. If they can contact me, I will share more study material with the proper explanation how this power is being saved. But there is no separate battery, but the same operation will be happening in our equipment itself.
Okay. So the next question is from Mr. Francis. How is the sealing happening without the liquid ring? And he has one more question. What will be the cost of Maglev compared to conventional vacuum pump? What is the expected life of Maglev vacuum pump?
Okay, the first question is how the sealing is happening without watering vacuum pump, right? Without water.
Yes, sir.
Yeah, here, see, no sealing is required. So what you need is you have to generate vacuum. That's all. You need to generate vacuum. In watering vacuum pump is a big impeller. You need the water as a seal to have the proper sealing because that. But in our case, when the RPM is very high, 75,000 RPM, and that vacuum is being generated on the impeller and directly connected with your application. So because of this, you don't need of water sealing in. And the second, the cost. I would say this is depends on the vacuum pump size, but general, I would say that we are supplying along with the VFD, also motor, steam water separator, and everything together. If you consider all the equipment cost, our cost will be around 30 or 40% higher than your watering vacuum pump. Yeah, roughly, rough calculation.
Okay.
So I forgot third question. Can you please?
Just one second, sir. There were only two questions from Mr. Francis. And next question is how many vacuum pumps have been installed in India so far from Mr. Varun?
Yeah.
And from Mr. Amitabh Srivastav, there is a question similar to vacuum pump. Are there other equipments like blower, fan, compressors with maglev technology?
Yes. Okay, so in India, we have already taken 16 vacuum pumps order, and four have been installed recently under final, fine tuning going on. So balance 12 vacuum pumps yet to install. It is on the way. Like Sripadi, as I said, that we already delivered. We are yet to install. So total 16 pumps orders have been secured in India, and four are running now. And yes, the another one, vacuum pump is the one equipment. Also, we have a blower, air blowers, and we have a compressors, and also we have all Maglev technology only, and also we have chillers. These are the equipments. So I think it's mute. So please unmute it.
We have Ms. Girisha and Mr. Ravichandran who had raised their hands earlier. So I'd request Mr. Ravichandran, I think he has raised his hands for quite some time, to please unmute himself and ask his question. Mr. Ravichandran VP. Mr. Ravichandran, is my voice audible to you? Okay. Okay. So in the meanwhile, we'll take another question. Mr. Francis is asking, have Maglev vacuum pumps been installed in thermal power plants?
Yes, plenty. Lot of thermal power plant is using our Maglev vacuum pump in China and global, but not in India.
Sound
So
is there, sir. I'll connect. I'll just connect.
One second, sir. We'll just let the speaker answer the question, then we'll take your questions.
yeah.
Ramesh, sir, you may continue, please.
Yeah. So thermal power plant, yes, they need a vacuum pump, and we have installed a lot of in China and abroad. But in India, we are discussing with NTPC, National Thermal Power Corporation, for this Maglev vacuum pump. Yes, we have installed. Please unmute, Mr. Vinay. Mr. Vinay Vijayan, I think you have to unmute.
Miss Girisha KJ, you can unmute yourself and ask your question. You had raised your hands earlier. Okay, Mr. Sunil Jolly has a question. What is the tentative maintenance cost for a
Yes.
Maglev vacuum pump?
Yes. So from Magli supplier side, they call this a maintenance free. Okay, number one, there won't be any cost because each and every component is having 20 years life, design life, and 4 years replacement warranty. Even though there is a filter, air filter, which is inbuilt, is assembled in control cabinet, that filter needs to be cleaned based on your atmosphere. If the polluted one, maybe 2 months once you have to clean. While machine running also, you can open and clean it, not necessary to stop. And that is the continuously cleaning the air filter is the only maintenance. Other than that, there is no other maintenance work or cost involved.
Hello.
Okay, Miss Girisha, you have been unmuted. You can
Yeah, it's a
raise your
very
question.
nice presentation, sir. After going through this Maglev pump, actually we are using this water ring vacuum pump for our vacuum system. But it is showing newer this new Maglev vacuum pump. It's a different. Actually, due to our aged in vacuum equipment, actually we are using the system only for 2 months. So it's a nice actually. We'll see. We'll think about it.
Okay, thank you.
So Mr. Sandeep has a question. Any scope of scaling and separator and cleaning system?
Yeah. Yes, we have the demister system. We saw that the some plastic PTFE plant. So if a lot of pulp is accumulated inside, the 2 months once or 3 months once, based on the scaling, you can easily remove. We have a door. You might have seen. I'll just show you that. Yes. So you can see there is a door. This we can open all the screws. If opening, all the demisters can be removed one by one. And by using the pressurized water and water gun, you can clean it simple. So maybe within 30 minutes or 45 minutes, you can clean the entire inside the scaling if it is anything is there.
So one last question, sir. Mr. Shami has shared a question. In transformer manufacturing, vacuum applications like drying and oil filling are mostly intermittent. In such cases, how suitable are Maglev vacuum pumps compared to conventional systems in terms of efficiency and ROI?
Sorry, come again, this question.
So the question is, in certain types of manufacturing processes, vacuum applications are intermittent. Continuous generation of vacuum is not necessary. So
Mhm.
in such cases, uh, how can we compare Maglev vacuum pumps with conventional systems in terms of efficiency and ROI?
So you mean to say that vacuum pressure is inconsistent, is not a constant one? Is it like that?
No, sir. The requirement of vacuum itself is not continuous. Only
Hmm.
intermittent requirement is there. During
Is that,
1 hour, they might require vacuum for half an hour or say 20 minutes.
that is maybe a special application we need to check. We need to have more details. Then only we can compare and give answer. So,
Okay.
yeah.
So, sir, I think quite a few of our participants have requested for your contacts. I'll be sharing your contacts with them.
Yes,
And some of our participants have also requested for case study papers. So I'll request you to please share your presentation. We'll share those with our participants, whoever has requested for them.
sure.
And I'll request Krishnan sir, sir, questions from your side, sir, and closing remarks following your questions, sir.
In fact, I wanted to ask some questions because we are going to install this, but the presentation was so explicit and it
Thank,
was so candid and it covers everything. So some of the my apprehensions of the questions are answered. Thank you so much, Mr. Ramesh.
thank you, sir.
And only one thing what I would like to touch upon is these type of, let it be Sangfang, let it be Maglev, let it be things. We are more concerned about the technical support and the service support from these guys. So I would like to understand whether you have a total setup within the country or you still depend on them or you are working with some outsourced agency.
Yes, it's a very important question, sir. Thank you so much because this is very critical question and important. See, I am employee of this company. This company is having long vision that, the last 15 years I am dealing with the Chinese from right from Zibo watching and all. But this company is very different because they want to stay in India for long period. So they recruited 22 engineers, all mechanical, electrical, and instrumentation engineers. All are Indians, and they have been posted in China for 2 months complete training on installation, commissioning, and this thing. Even myself, I stayed there for 2 months for the training only. Understand that because for me also it was new last year, so I stayed there. So basically, in each and every state, we are going to have means already we are having three engineers. For example, if we take Tamil Nadu, in Madurai itself, we have engineers, and in Chennai we have engineers, in Coimbatore, in Vapi, in Delhi. So this company is having long vision. First we recruited people, after that only we have taken order, because it is a very critical equipments. We need a continuous support. One good thing is we have a 24 by 7 customer care number, because if a watering vacuum pump anything goes wrong, even operator itself he can solve, because he is seeing this technology for so many years. But this technology is new even for any. So we have a 24-hour service support this company is providing. Even midnight, 12 o'clock also they can call and get the support. So this is the, and warehouse, even if any critical parts, anything is required, we are keeping it. So we have a commitment that within 4 hours, the spare parts will be delivered to the site. Like that, we are having it. So before taking the order, we have first make sure that after sales and service is taking care.
Thank you. Thank you so much, Mr. Ramesh. One more, somebody was asking about the turbo and the requirement of intermittent vacuum requirement and things like that. But the thing is, I would only like to say based on the experience with the old traditional Kakati watering vacuum pumps and man turbos and other sanction blowers and all. See, wherever we have troubles related to inconsistency or insufficient vacuum
Mhm.
in the paper making process, where you are blowing, crushing, where you have a lot of paper breaks and those type of things. I would tell you, gentlemen and ladies, whoever is here, it will become history for you. You will have a very, very stable vacuum. If you
Mhm.
want minus 180, you will have minus 1. If you want 550 to for 600, you will have 550 to 600. But the selection of the vacuum pump for the airflow
Mhm.
and the capacity, at that time you have to put a lot of information, you have to put a lot of calculation, then you have to study the correct blower. correct vacuum pump model. Then after that, your vacuum requirement will be nicely fulfilled very consistently. Your 60% of your paper making, especially multi-layer board making problems will be taken care of. The second one is very intermittent type of, I'm taking liberty from Ramesh and then answering this. And the second one is the intermittent requirement of vacuum pump. You will not get the benefit what he was projecting it today at 35, 40, 45 and all. Because it all depends on heavy vacuum requirement on a consistent basis, day in and day out, 24/7. So you can nicely quantify the benefits. Otherwise, it's very difficult. And the last point, I would like to only compliment Mr. Ramesh that it was not like a speaker just taking a technical session on CAI. It was like a training program. And excellently, you have done that. And every slide that you have compared technically what the difference between your traditional vacuum pump and a blower and yours, and also the saving potentials with case studies and all. I think many will be interested in, and it's a good knowledge gathering session. It's a training program. Thank you so much. Thank you so much for CA arranging this, and all the best, Mr. Ramesh. Thank you.
Thank you so much, sir. Thank you. Thank you. Yeah.
So, thank you so much, Krishnan sir. Thank you so much, Ramesh sir.
Yeah.
Thank you. Thank
That brings us to the end of this session. This was the sixth session in the Future Ready Paper Mills web series. We'll have the next session in the month of July. And before going, I'll also like to share some information about some of the other activities that we have. We have our Paper Tech coming up in the month of September. It is our annual event for the paper sector itself. The theme is Make Indian Pulp and Paper Industry World Class, and it will be running parallelly with the Energy Awards, where again we have integrated, non-integrated, pulp-based paper mills who have applied for the Energy Awards this year. So do block your calendar 16, 17 September 2026. This will be a physical event in Hyderabad. Do participate. And with that, I'll come to the end of this presentation, this session on vacuum system modernization and paper mills from liquid ring vacuum pumps to Maglev vacuum pump system. Thanks a lot to Krishnan sir for taking time out from his valuable time. Thank you so much, Ramesh sir, for the wonderful presentation. And thank you to all the participants for being so engaged, being so active, so many questions. Multiple participants have asked for your contacts. I'll be connecting them with you shortly. And uh, very good day to all of you. Thank you so
all
much.
the best wishes to all the participants. Thank you so much.
Thank you so much. Thank you.